Hello. Hey, I'm on. Thank you very much. It's great to be here at Swift Heroes again, actually, and talking to you about Swift Package Manager. So today I'm going to kind of explain how Swift Package Manager works, what it is, why we need it. But then I'm also, the second half of the talk is going to be kind of a live demo. I'm going to show you how to actually use Swift Package Manager in your apps today. So, quick introduction before we get going. I run a company called Broken Hands. We do consultancy and training and workshops, but purely for server-side Swift these days. I'm also the server-side Swift team lead at raywindlick.com. So completely unbiased when it comes to server-side Swift. And you can find me on all the kind of social media stuff and Twitter and GitHub and Slack, etc. 0xTim. And I organize a number of meetups and a conference around the world. So I organize one of the co-organizers of server-side.swift, which is a conference dedicated to server-side.swift, which was held just a couple of weeks ago. So I'm not going to talk to you about server-side Swift today, surprisingly, but you should all definitely use it. So, package managers. Hands up here if you use package managers. Not that many. All people aren't listening. So why do we need package managers? What purpose do they solve? Well, so let's take an example. Let's say you're building your first iOS app or an iOS app, and you're kind of coding away, but you don't want to reinvent the wheel. People have written code libraries for you, and you can just integrate those. So at some point in the future, let's say you need a networking library. So you go to GitHub, you install the CocoaPods, and you get your networking library. And this is great because you can make your network requests, and it handles all that for you. You could do certificate pinning if you want without having to worry about it. And then at some point in the future, you also want an image caching library. I think that's cool. But the image caching library also requires the network library. So how do you make sure that those two things work? So in our case, the image caching library relies on version 2.1 or greater of the network library. But that's fine because we're currently using version 2.1.3. So it all works. And then at some point in the future, you also need a graphing library. Let's say you want to draw some fancy graphs in your app. But the graphing library also relies on the image caching library, and that requires version 1.4 or greater. But that's fine because you're actually using version 1.4. So this all kind of works, but you have to make sure all of those dependency versions work yourself, and you have to do it manually. It also relies on network library, but in this case, it relies on version 2.2 or greater. And that's a problem because you've got version 2.1. So you have to go and get 2.2 or greater, make sure your code still works with it, and update it manually. But that's OK. We can do that. But then you get to the case where at some point in the future you want a media player library, let's say to play back some videos in your app. This is quite an old library, but it still works and still compiles. But the media player library actually relies on a network library. But because it's old, it requires version 1.0 up to, but not including 2. So you have a dependency conflict here, which means that you can't compile your code because your media player library relies on an older version of the network library. And so you have to kind of work out how to solve these issues. But in these cases, it's not too much of a problem because you're manually importing each of the dependencies. So you're pulling in the network library, you're pulling in the graphing library and the image caching library. But let's take another case where you want both your image caching library and your media player library, but they're both using an image encoding library that you don't actually know about and that you don't use yourself. So you have to work out why it doesn't build, go and get the image encoding library, make sure you have the right version, put it in, build it, link it against the 2 other targets. It's a faff. It's quite painful. And this is the thing that package managers are designed to solve. So there are a couple of package managers out there. There's CocoaPods and Carthage. I'm sure many of you use them currently, and they do quite a good job. But there is another tool in town, the new kid on the block, called Swift Package Manager. So what is Swift Package Manager? Well, according to GitHub, it's a tool for managing the distribution of source code, which is actually just rubbish, because it's actually a build system, a dependency manager, and quite a powerful one. It was actually released with Swift 3, so it's been out for a few years now, even though most people in the iOS world haven't really used it. But if you've been working on kind of Linux or in command line apps, the only way to build your apps was using Swift Package Manager. So it's been used by the Swift server community since the beginning, basically. And we've been the ones who've had to bug fix it and make sure it works and battle test it. However, this year at WWDC, with Xcode 11, Finally, we got first-class support for Swift Package Manager, which means that you can do all your Swift Package Manager stuff in your iOS apps. And the other great thing about Swift Package Manager, like the other two package managers I showed you, it's open source. So if you want a new feature, you can pitch something on the Swift Evolution forums and get it implemented. You can commit bug fixes to the code base, and you can work out what's going on. So how does it work? So all Swift packages are based on the manifest file. And this is your package.swift file. It lives in the root directory of your package, and it's the single source of truth for that package. If you're coming from CocoaPods, it's kind of a mixture of the pod spec and the pod file. But it is the only thing that you need to build a Swift package, which means that you do not need an Xcode project if you're just building a plain Swift package. So those of you who have ever been working on multiple teams with multiple people, where someone adds a file and someone else adds a file, and you have to merge and resolve that merge conflict in some weird XML hell, doesn't exist anymore. Goodbye conflicts. Swift Package Manager takes all of that away for you. So this is what a manifest file looks like. It's not particularly interesting, but there is a lot in there. So let's go through it. So the first line is the Swift tools version. Weirdly, you have to have this, and it's a comment, and it has to be the first line of your package, otherwise it won't build. But this basically defines the minimum version of the Swift compiler that you support. And it also tells the compiler that's bringing in your Swift package what compatibility version to build your app with. So if you are using Swift 5 and you put in an app, a package that has a Swift 4 tools version, just like this one, up at the top, there. So that's saying Swift tools version 4.0. It will tell the compiler to build your package using the Swift 5's Swift 4 compatibility suite, which means that if you're using Swift 4 dependent features of the language, then they will still all work. Next, you need to import package description. This is a magical module that exists only with Swift Package Manager, but it allows you to kind of have access to everything you need. And then next, we create a package object. So this is a special type, and it requires a name and targets as minimum, but it is just Swift. So this is all Swift code. So if you need to define some environment variables to work out whether to put in a dependency, if you want to do some calculations or kind of computed properties, you can do all this because it's just Swift. And you don't have to go and learn Ruby or some weird other language because that's what that package manager is built in. It's all Swift and the language that we love. Next is the package name, which no one uses it. Don't know why it's there, but it might be used in the future. But it's useful for people looking at your app to work out what your thing is. And next, we have a products array. So this defines all of the kind of build artifacts of your package. You don't actually have to include it because Swift Package Manager will infer it. So if you're building an executable, you don't really have to worry about it. But it defines the publicly vended targets for your package. So if you're building a library and you don't include this, your package is pretty rubbish because no one can use it. So you must define that, and you define your name and what targets each library or executable is built against. Next, you define your dependencies. So this is kind of similar to what you will exist, and it's an array of packages. You can either use URLs or paths on the local system. So if you're developing a package locally, you can just reference that locally. And it supports doing version numbers. You can specify a branch to use. You can specify a specific commit if you want to pin to a specific commit. And then finally, we have the targets. And these are the basic building blocks of your package. There are two types of targets. There's a test target and a regular target. And it tells the compiler and Swift Package Manager how to link your different dependencies to which target. So you need to specify which of your targets link to which dependencies. Otherwise, the compiler won't link them, and you'll have compilation errors. So that was the hugely entertaining Swift Package Manifest file, but hopefully that's quite informative. So I mentioned right at the start that Swift Package Manager is actually a build system, and there are a number of command line tools that you can use to run, test, and build your apps. So there's the intuitively named Swift Build, which builds your package. There's Swift Test, which tests your package, and Swift Run, which actually runs your executable if you have an executable. And there are others, such as Swift Package Resolve, which will resolve dependencies. You can do Swift Package Update, which will update the dependencies on the command line. And all these are great for CI. So if you're building an app or a package which only relies on Swift code, as Shai talked about earlier, his app, it means you can run it on Linux, but it also means you can run your tests for your package on a CI on Linux. So you don't have to worry about finding a Mac OS box to run. You can just put it into the cloud and run your package tests. So, up till now, we've been kind of talking about Swift, and it's called Swift Package Manager. But there are some other features that you might not actually be aware about. And this is where it kind of starts to get a bit more interesting and shows you how you can use it in your apps currently. So many people don't actually know, but Swift Package Manager can build more than just Swift. It can actually also build other C family languages, including Objective-C and C. So if you have an existing app that has some Objective-C in it, don't be worried, because you can actually build it. And I'll show you how to do this in a demo in a bit. There are some rules about this. So C languages must live in their own targets. So you can't mix Swift and C in the same target. But if you have an app which has Swift code and Objective-C code, they both need to be public anyway to be able to see each other. So that's not really much of an issue. And to make this work, you basically create an include directory, and then you put all your public headers in there. And that's what auto-generates a module map for you. So Swift Package Manager will synthesize a module map for your C-style targets, which means it can be imported into Swift and it sees everything. If you have a really complicated setup for one of your packages, you can just provide a module map, but you don't actually have to do it, which is great, because no one likes writing module maps. The other kind of cool benefit of Swift Package Manager is because it's built into the Xcode project, it works alongside CocoaPods and Carthage. So if you have an app that has 100 CocoaPods dependencies, you don't have to kind of do a clean break and move all of those over to Swift Package Manager straight away. You can actually move them over one by one while still using CocoaPods for some of your dependencies. Now, obviously, if you're doing this, you have to make sure that the ones that are used by Swift Package Manager aren't required by any of your other dependencies in CocoaPods. But it is a great way to start slowly migrating over to Swift Package Manager if you want to. There are some caveats with this. As I mentioned, you can't mix code, so you can't have Swift and Objective-C code like you currently can with, say, CocoaPods. You can't import Swift targets into an Objective-C Swift package yet. That's coming in Swift 5.2, apparently. And you can't have cross-dependent code. So it means that an Objective-C module can't rely on a Swift module, and that Swift module can't rely on an Objective-C module yet. And again, that's coming in Swift 5.2 with some of the great new features in Swift Package Manager. So let's take a quick detour into semantic versioning. Now, hopefully, most of you are kind of used to semantic versioning, but we'll cover it quickly, because it's what Swift Package Manager uses to work out what dependencies versions to use. So semantic versioning is defined at semver.org, and it's a kind of industry standard for defining dependencies and libraries and what versions they are. So you version your packages as major.minor.patch. For example, 3.1.4. So a major change, so if you go from 3.1.4 to 4.0.0, that means you have breaking API changes. And this signifies to anyone pulling in your updated dependency that their code may not compile anymore because the API has changed. And that's a great way of telling your kind of clients or your customers or anyone using your frameworks that they need to change the API. The API has changed and they'll need to change their code. And this is why most package managers will only go up to a certain number. So you can do 3.1.4 up to anything but not including 4, because that generally denotes breaking changes. If you have a minor release, such as 3.2.0, this means there have been new API additions, but they are non-breaking. So let's say you've added a new API to your package, but it doesn't matter because anyone still using the old one can still compile. And then we have patch changes, and these are kind of bug fixes, anything else that doesn't affect the API. If you're changing your own internal dependencies, that's actually a patch fix, a patch version. So this is just going from 3.1.4 to 3.1.5. So semantic versioning also supports pre-release identifiers as well, as does Swift Package Manager. So let's say you have 3.10.1, but you're going to release 3.10.2 at some point. You can actually announce or release a pre-release of -alpha.1 And this kind of denotes that it's an alpha. It's going to become 3.10.2 at some point. But anyone using it can know that they don't have to take it because it's not an official release. And there are rules around this. So RC is greater than beta, and beta is greater than alpha. And RC.2 is greater than RC.1. So it means you can do kind of semantic versioning on pre-release identifiers as well, which is really useful for when you're updating your pre-releases. If you want to use pre-release software in Swift Package Manager, you can. You just have to make it explicit. So if you want to use a dash beta, you have to say you're going to use dash beta. Otherwise, it won't put it in. But when you actually do get a release, it will automatically update to the non-beta release. So you can start using the beta, and then when you do an update, package update, it will automatically pull in the latest release, which is great for keeping updates and making sure it all works. So you're now thinking, great, I'm going to go and use Swift Package Manager right now. But we should talk about some of the limitations first, because there are a couple of big ones. And there are still quite a few of them as well. So currently, with Swift Package Manager, there is no support for resources or binary dependencies, which is a big blocker for most people. However, there are a couple of pitches, or proposals, sorry, on the Swift Evolution forums. There's 0271 and 0272. They went into review on Wednesday, and they will implement support for resources and binary dependencies, and they should be shipped hopefully in 5.2, maybe 5.3, depending on when the release is cut. And this will allow you to kind of pull in images and nibs and kind of anything else you want as your resources, if you depend on those, and if you depend on some kind of closed source third-party framework like Firebase or anything like that, you can actually define that as a binary dependency, and it will actually work now. So those are two big proposals that will massively increase the adoption of Swift Package Manager. There are a couple of other minor limitations. So test dependencies will always be cloned. So if you rely on a testing framework just in your tests, anyone pulling in your library will also pull in that testing framework. They won't actually compile it, but they have to clone it, which is a bit of a pain. But it's not the end of the world. And currently, there is no support for build phases or settings or scripts or et cetera, et cetera. So it's not going to be replacing Xcode projects for iOS applications just yet. Although I have met the guy who created the Xcode project, and he says he's trying to get rid of it. So fingers crossed. And finally, Swift Package Manager itself will only implicitly link against Foundation and XCTest. So if you have created a Swift package that relies on UIKit, you won't be able to build it from the command line. You'll need to build it using Xcode because there's no way to say that you rely on UIKit in your Swift package, which is fine for the most part. And one last point, actually. For those of you who want to go and test your packages on Linux, just be warned that Linux Foundation is not the same as Objective-C Foundation. So when Swift open sourced 2015, I think, end of 2015, they actually open sourced Foundation as well, but it's a re-implementation of Foundation written in Swift. And there are a few landmines still where you'll hit some things that will blow up, some things aren't implemented, and some things aren't tested. But these days, it's mostly OK, but it's something to be aware of if you're going to start testing on Linux. So how do you use Swift Package Manager with iOS apps? Well, it's actually a bit of a special case. So if you want to use Swift Package Manager with iOS or tvOS or watchOS or even macOS Xcode targets, it's a bit of a special case and a bit different to every other package, which is weird because it's probably going to be the most popular use case. So in the iOS world, if you're using Swift Package Manager, there is no manifest file, unfortunately. You have to define everything in the Xcode project. And this is all held in an internal database inside of the Xcode project, which means that you can't edit it, you can't change it, you can't manually update it. So you have to use the Xcode UI to do all of this, which is a pain, but I'm sure they'll change it at some point in the future. Once kind of the package manifest file has support for resources and build phases, et cetera, et cetera. So this is great. So you want to go and use it. How do you find some packages? There are currently over 10,000 Swift Package Manager packages currently on GitHub, which is quite a lot. Most of these have come from the server-side world. But because they all are just based on Linux, most of them will work in iOS projects. Doesn't mean they're useful, though. So don't go out and grab everything you can. Don't take inspiration from the Node.js community, where you have a package to create a red color, and a package to create a green color, and a package to create a blue color. Just use the useful ones. Discovering packages is something that's a hot topic at the moment. Back at DubDub in June, GitHub announced there's going to be support for the package registry. It's now called the packages list. So that hasn't currently been defined on how it's going to look. No one really knows. One of the GitHub engineers put something on the Swift forums last week about what this might look like. There are community offerings as well, so people scraping GitHub to find packages. But there are lots and lots of discussions from both Apple. They did a video at DubDub last year trying to work out how this is going to look like, and they wanted input from the community. GitHub, as I've said, and also community members writing on Swift forums trying to define how we're going to find packages. So Swift Package Manager is a decentralized package manager repository. So with things like CocoaPods or with things like NPM with Node.js, they have an internal database or their own database where they store all the packages, which means that you can look up packages, and that's great because they're all there in that list. But it means you have a single point of failure. So if that goes down, no one can build any packages. It also means that they're the one kind of source of truth. And do Apple own that package list? Do GitHub own that package list? It's a bit complicated, and no one really knows the answer. So if you have any kind of thoughts, get on the Swift forums and suggest them. One notable mention is swiftpm.co, which is a website written by Dave Verwer, who creates the iOS Dev Weekly newsletter. He's written a website that will scrape GitHub and kind of find all the packages that it supports for Package Manager, give some information like the README, how many stars they have, what versions of Xcode they support, etc. So that's quite a useful tool at the moment. Or you can kind of search on GitHub for the Swift PM tag for those people who actually tag their libraries. Right. So that was a whistle-stop tour into kind of how Swift Package Manager works. But let's actually see how to use it. So hopefully this mic is on, because I need to do some typing. Okay, right, let's make it visible. Can you see that at the back? Awesome. Okay, so I have a little app here. It has a backend, so I'm going to build and run this. It's just a Vapor app, and it serves up an API for a Today I Learned application for learning fun little acronyms. And then I have an app here that's basically a very simple table view. I'm sorry it's not Swift UI at the moment. I haven't had time to convert it. But it has a list of acronyms, it has a list of users, and it has a list of kind of categories that you can tag your acronyms with. So this app at the moment uses CocoaPods, as you can see, because it pulls in Alamo Fire. So there's Alamo Fire down there. But I want to kind of get rid of this, and I want to get rid of CocoaPods and move to Swift Package Manager. So I'm going to stop the app. I'm going to go to terminal. Let's move that over the where so I can see properly. So this is my iOS project. So what I'm actually going to do is I'm going to type pod deintegrate. Oh dear. Nothing to see here. This is Catalina screwing me over. And that's also the wrong thing to install as well, isn't it? Oh. This is why you don't do live demos. And I bet the Wi-Fi is not going to work either. Okay, so let's pretend we never saw that. So I have an Xcode project here that has Alamo file removed and all the CocoaPods are gone, if it works. Okay, so this is just an Xcode project. You can see I've actually added Alamo file here, but I'm going to remove that and show you how to use it properly. So if I build my Xcode project now, once Xcode catches up, okay, so we'll cut out the last few minutes. We can edit out in the video, it's fine. So I have an iOS project here where I've completely removed all trace of CocoaPods. So I've just opened up the Xcode project. So I've removed the workspace, I've removed the pod file, and I've removed the podfile.lock. So if I build this now, I actually get a build failure because it can't find Alamo fire. So I'm going to add Alamo fire as a package dependency. So to do this in Xcode, you just do Swift packages, add package dependency. And here you can enter a URL, or you can actually search for packages. So I know I want Alamo fire, so I'm going to search for it if the internet's going to work. This did work earlier. Luckily here I have the Alamo fire URL. So I'm going to put that in there. And what this is going to do is it's going to go to GitHub, make sure it can see the Alamo file URL, make sure it's a valid Swift package project, and then pull it into the app. So, if you go to Xcode, if you click package dependency, you can hopefully search for it this time. And this will kind of find anything in GitHub that has Alamo fire. So you do need to be careful because it will find all of the forks as well. So I'm going to pick the one that's by Alamo fire. And that's going to kind of fetch the repository, make sure it's a valid Xcode project. So you can see this one's got all the stars, so that's probably the right one. So you go to next. It then looks at the package.swift manifest file and finds the correct version. So you can choose whether you have the minor, a range, you can choose branch or commit. I just want up to next major, which is 4.1.9 up to but not including 5. And this actually then clones the dependency and then will integrate it into your Xcode project for you. Hopefully. And if this doesn't work, we're going to see a demo of how you can integrate Swift Package Manager into a project that already uses CocoaPods. Yay. I think getting the Wi-Fi to work is not deserving of a clap, but thank you anyway. So you can see I've found the Alamo fire package, and then you can choose which target to add it to if you have multiple targets. And then you can see it comes up in your Swift package dependencies. And then if I build that now, it should all work excellent. And I can build and run the app, and it's now making a network request using Alamo fire from Swift Package Manager. So that's great. But what about creating your own Swift packages? So in my code here, I have a few models for the acronym, for the user, and for the category. They're just generic Swift classes that I'd like to be able to share, because I actually want to share this code with my server as well, so I don't have to duplicate all the code. And if I add new properties, it automatically converts it for JSON and stuff. So I'm going to create a new Swift package And I'm going to call this TIL core. I'm going to find the right one to put it in. And then I'm going to add it to the iOS project and the iOS group. And this creates a package, Swift package template for you. So you have a README here, where you can add information. You have your package.swift manifest file. You have your sources, which for now is just a very simple struct that I can get rid of. And it also creates some tests for you, so you can run your tests, and it all links correctly. However, for now, I'm just going to drag the models into my TLL core package. And that's now part of my TLL core package. So if I build my app now, it's going to fail, obviously, because it doesn't know where those symbols live. So first, you need to go to your target, add the package. So this automatically comes up. So that will then link your new package against your iOS app. And then if you build it, you should get some build errors because it can't see the symbols. So you just go into your file and you do import TLL core, and that will get rid of the build errors for that class. And you just do it in each of your classes where you are sharing the models. And that one. And that one. Cool. So this is now using the models from my Swift package that I've just created. And that means that I can then share that Swift package with anyone else. I can share it with my server code. I can share it with any other apps that need those models as well. And this is all using Swift Package Manager. Now, the final thing I want to show you is I have some, in this class here, some fun Objective-C code. And this is actually quite a useful piece of Objective-C code because it shows an error presenter whenever there's an error. And this is quite a cool thing to share. So I'm going to create a new Swift Package Manager and build my Objective-C code in my Swift Package Manager. So again, you do File, Swift, New, Swift Package. And I'm going to call this Error Presenter Kit because every good package should be suffixed with kit. And again, I'm going to add it to the iOS project so I can see it. And again, this creates Swift package. You have your package.swift manifest file, and you have some generic Swift code, but I'm actually going to delete that because I don't need that anymore. I'm going to then create a new folder called include. So this is where my public header files are going to live. So I'm going to drag my header file that I want to expose to the rest of my apps into the include directory, and then the source file. Force touch, man. And then the source file just goes into the package in that directory. And this will build my Objective-C code, and it will vend it as a module that Swift can then see. So the last few things I need to do is delete the bridging header, because I no longer need that, and then get rid of it from my build settings. And then I can now link my package again, up, and build and run it. And this will build the Objective-C code and then link it against my iOS Swift target. And again, you can't see it because it doesn't know what error presenter is. So you just import your new module. And last one. And that's now built. So if I build and run my app, it should all work, and should all work using both Swift and Objective-C code built by Swift Package Manager. And there we go. So just to prove it does actually work, I'm going to kill the server and make requests to users, and I get my error presenter. So that was using Swift Package Manager in Xcode 11 with iOS projects. You saw how to change dependencies from CocoaPods and use it with Swift Package Manager with Alamo Fire. So that's how you include new dependencies that you can find on GitHub or Bitbucket or any Git URL. You saw how to create your own packages and use them in your iOS app. So if you want to extract out some Swift code into your own package, so let's say you have a big app, a big monolith app, and you want to break it up into nice little frameworks, that's how you do that. And there are some great talks later from Julia and Vadim talking about how to make good packages. And then finally, we saw how to actually create a Swift package using Objective-C code. So for those of you who are working on legacy code bases, and I've worked on many legacy code bases that are still 90% Objective-C, you can actually still start moving to Swift Package Manager now and build your Objective-C code using Swift Package Manager, which means that you don't have to worry about CocoaPods, you don't have to worry about managing workspaces, and you can start moving. So that was Swift Package Manager. Thank you very much.